transformer essentially changes electricity from one voltage to another. A failure in a transformer means power in a large part of a city goes down. These transformers generally cost between 3 to 10 million dollars and take around 12 to 18 months to manufacture. So in our simulation, we created TransformerTwin, which is a simulation of a real-time digital twin that mirrors a physical asset. In our case, we've tried to mirror one of the transformers that GE Vernova may have, and it runs physics models to predict the state of the transformer and provides diagnostics a human engineer would find valuable. So, uh, at any point, we're uh, observing the sensors and seeing the current state of the oil temperature of some gases, the fan state, and we also have DGA, which is the dissolved gas analysis. It is an early warning system. So when faults develop inside transformers, it generates specific gases that dissolve into the oil. We have the Duval triangle, which is a standard method for classifying what type of fault is active. We can observe the trends of the different gases that we're uh, monitoring, and we can get a summary as well, which tells us in a nutshell what the stage is of the different gases and their concentration. We also have the failure mode and effects analysis. So rather than alerting on a single sensor threshold, FMEA correlates multiple signals to diagnose the root causes. Now, the main killers of transformers are like when a hotspot develops. This occurs when there is high load or cooling failure. The paper degrades, insulation fails, and a short circuit eventually develops. There is the arcing event where electric discharge inside the oil and instantly destroys the insulation, may cause the tank to rupture as well. There's partial discharge, which slowly erodes the insulation over months, cooling failure, paper degradation, and oil contamination. Now we can start by simulating some events. Let's say developing hotspot, for instance. We can see that we get a warning that there's winding hotspot temperature anomaly has been detected. We can go ahead and see the recommended actions. We have to reduce the load. So we do have a decision panel here as well, where we can control the load and enact different type of cooling failures, cooling modes as well. Right now, we're getting a asset risk assessment of low, and the live prognosis gives us further data as well. Maybe we can speed up the simulation to see d changes in different places. You see the winding temperature, the model predicts that 35.8 should be the correct temperature, but the actual is rising and it's rising pretty fast uh, in this situation. The health still is okay, but the time to critical failure is degrading. And yeah, if we act now, we can be offset with just 16K, but if we let let it go and have a failure, it'll end up costing us $3.8 million. Now let's go ahead with the arcing event and have a look. It asks us to reduce load to minimum immediately. Anomaly has been detected. We need to reduce the load. So we can go ahead and do that. Uh, it's auto load capped at 40% based on the event that has been going on. And we see lots of alerts now based on this situation. FMEA predicts that all the four conditions have been met for an arcing event, and it gives us some recommended actions as well. Now let's take a look at a situation which is a thermal runway where a lot of cascading failures start to happen. So we can see while all this is happening, we can get some idea about the state of the physical transformer as well. We know that the DGA failure is happening, so it's critical, and it gives us the sensor reading as well. C2H2 is at a bad state, at a critical state right now. It's asking us to dispatch the maintenance crew. The health index is degrading. Estimated time to critical is 1 simulated hour. And we see some parts of the tank aren't doing so well anymore. Let's try paper insulation degradation now. You can see the top oil temperature anomaly has been detected. It gives us the recommended actions as well. And finally, we can probably look at the partial discharge event as well. Let's schedule ultrasonic partial discharge test. So this is our simulation where we can monitor the tank and the transformer, different parts of the transformer, visualize it and observe it, take actions based on the digital twin. This can be useful in a variety of applications such as predictive maintenance and observability of the transformer states. Thank you very much.